This is page 4 of unit conversions. Number 7. Well, first of all, let's look at this formula I gave you. Volume is equal to length times width times height. We're going to use that on this page, okay? So 7, a cubic container has sides that are 1.5 meters long. Now remember, a cubic container is like a three-dimensional square. So by giving us the one dimension of 1.5 meters long, we already know all three dimensions are 1.5 meters long. Okay, so first it says to find the volume of the container. Since we know that volume is length times width times height, we know that volume is equal to 1.5 meters times 1.5 meters times 1.5 meters, also known as 1.5 meters cubed. And if we want to know how much that is, let's use the calculator. And it's 1.5 cubed. You can use this little caret to do cubed. And the other way you can do it is write 1.5 times 1.5 times 1.5. Okay? But either way, you're going to get 3.375. So the answer is 3.375. And what are the units? The units would be meters cubed, because the meters are multiplied 3 times together to get the units too. That's part A. B, give your answer to part A in decimeters cubed. Okay, so now we need to go back and look at what is a decimeter compared to a meter. And our domino in this case would be that 10 decimeters are equal to 1 meter. So let's take 3.375 meters cubed, and we're going to change it to decimeters by multiplying times 3 dominoes that have 1 meter in the bottom of each, because we want to cancel 3 meters multiplied together. And of course, our domino is going to have 1 meter on one side of the domino, and the other side of the domino is going to be 10 decimeters, 10 decimeters, and 10 decimeters. And the reason why we put the meters on the bottom instead of the top is so that we could cancel the meters, so we could get rid of them. And then the decimeters go on top because we want those units left over. So 3.375 times 10 times 10 times 10. If you do it on the calculator, you'll see it's 3,375 decimeters cubed. So that's the answer to B. C, decide whether 4,000 liters of water can be poured in the container and justify your answer. Okay, it would be nice if we had this in terms of liters, and we don't. We have decimeters cubed. But remember that decimeters describe 10 decimeters are 1/10 of a meter. So actually a decimeter is also known as 10 centimeters. And if you make a cube of 10 centimeters by 10 centimeters by 10 centimeters, that is 1,000 cubic centimeters. And remember that 1,000 cubic centimeters is a liter. So actually a decimeter cubed is a liter. So we know that 3,375 decimeters cubed is equal to 3,375 liters. And now we know that that is less than 4,000 liters. So we cannot pour 4,000 liters into a 3,375 liter container because it's smaller, right? Let's go on to 8. The volume of a teacup is 220 cubic centimeters. Mercedes always serves a teacup to 4/5 of its capacity to avoid spilling any. Find in liters the amount of tea that Mercedes serves in a teacup. So if we knew that that she was going to fill the teacup all the way, this would just be a unit conversion of 220 cubic centimeters. But since we know that she only wants to serve it to 4/5 of its capacity, then we know that we need to adjust the 220 centimeters cubed by 4/5, right? So instead of 220 centimeters cubed, let's find out what 4/5 of that is, okay? So 4/5 of 220 centimeters cubed is 220 times 4 divided by 5. 220 times 4 divided by 5. 176. So 176 centimeters cubed 176 centimeters cubed is what we're going to fill up. And we want to know what that is in liters. Remember from our previous problem that 1,000 centimeters cubed is a liter. So what we're going to do is we're going to multiply it times a domino with 1,000 centimeters cubed in the bottom and 1 liter on top, so that we can cancel out the centimeters and just be left with liters. So if we do 176 divided by 1,000 on the calculator, we'll get 0.176 liters. Part B. The volume of Mercedes teapot is 1.5 liters. Find the maximum number of teacups that Mercedes can serve from one teapot. Okay, so you could do this with algebra or without algebra. So if you were going to do it with algebra, you would say, okay, I want to know the maximum number of teacups, so we'll call it N, times 1 teacup, 0.176 liters, is equal to 1.5 liters. And then we'll say, okay, now we divide both sides by 0.176 to find the number of cups. And the liters, you can see, are cancel out because we end up with the number of cups. So we go 1.5 minus 0.176. And we get 1.324, I'm sorry, 1.5 divided by 0.176, right? And the answer is 8.52. Okay, so the number of teacups that we can serve is 8.52. So they're asking for the maximum number of teacups. In math studies, you have to be careful that when they ask that, they're looking for a whole number. So you would say that the number would be 8. It wouldn't be 9 because we don't quite have 9 cups. So only the full ones count. So we'll say that that is worth 8 teacups, okay? 8 cups. The other way you could do this is without algebra, is you would say, okay, I start out with the 1.5 liters, right? And I'm going to put that there. And then I'm going to subtract repeatedly 0.176 liters over and over again to see when I run out. And every time I subtract, I'm going to count 1 cup, okay? So subtracting 1 time would be 1 cup, and I'm left with 1.324. Then I subtract another cup, 2nd cup, 3rd cup, 4th cup, 5th cup, 6th cup, 7th cup, 8th cup. Uh-oh, next time it's going to run out, right? 9th cup. So you see, so really we only got 8 cups out of it. So I can do this just by repeated subtraction also without doing algebra. Okay? All right. So let's go on to number 9, which is the last problem on this page. To do this problem, we need to know that speed is equal to distance divided by time, okay? So the distance by air from Buenos Aires to Cape Town is 6,900 kilometers. An airplane flies at an average speed of 800 kilometers per hour. Now this notation here means 800 kilometers per hour. Just to remember that if you have hour to the -1, that is equal to 1 over the hour. Find the time it takes for this airplane to fly from Buenos Aires to Cape Town. So we want to know time, and we have speed and distance. So let's write out this formula here, fill it in. So we'll put speed is 800 kilometers per hour, and equals distance, which is 6,900 kilometers, divided by time, which is unknown. And now, if we want to figure out what time is, all we need to do is do a little bit of algebra here. So I could multiply both sides by time to get t in the numerator, and then I'll have to do a little bit more algebra. So if I multiply both sides by time, you can see that I'll have time here, and I'll have time here, and I could cancel out the times here, and I'm just left with time on the left. But now I have this 800 I want to get rid of, so I'm going to divide 800 by both sides, okay? And then I'll have t equals 6,900 kilometers divided by 800 kilometers per hour. And that gives me 6,900 divided by 800. And that gives me 8.625. Okay? and that unit is hours, which comes from the bottom there. Okay, so in 8.625 hours, that's how long it takes for the airplane to fly. Another way you could do this is with let me think of what it's called, cross multiplication. So whenever you have a variable in the bottom, one of the ways to get it out of the bottom is to do cross multiplication. If you remember cross multiplication, you multiply like that. So in this case, I'm going to multiply 800 kilometers times t. And on the right side, I'm going to have 6,900 kilometers times hours. Okay, and then I'm going to divide both sides by 800 kilometers to get rid of 800 kilometers, just like I did before. And then I'll end up with 6,900 divided by 8, which gives me 8.625. And that gives me 8.625 hours, just like before. Okay, so whichever one, just straight algebra or cross multiplication, that's a way of getting, adjusting this equation so that time is no longer in the denominator. And there's a couple other ways to do it, and if you didn't like those two ways, call me over and I'll explain a different way to do it, okay? B. Abawo takes this flight and flies to Johannesburg, which is 1,393 kilometers from Cape Town. The flight is 2 hours long. Find the average speed of this second airplane. Okay, so let's see. We're going to use speed equals distance time again. And we're going to have a distance of 1,393 kilometers. And that's divided by the time, which is 2 hours. And the speed is unknown. We're finding the speed this time. This time we don't have to rearrange the algebraic equation, which is quite nice. So we're going to take 1,393 and divide it by 2. 1,393 divided by 2. And we get 696.5 kilometers per hour. Okay, and that's it for B. C. Abao leaves Buenos Aires at 10 a.m. When he arrives at Cape Town, he waits 1.5 hours until the next flight. Find the time at which he arrives at Johannesburg. Okay, so basically he's going to take the flight that we calculated, the time in A. He takes the flight that we know takes 2 hours, second, and in between he waits 1.5 hours. So let's figure out how much time total for the 2 flights plus the waiting. That would be 8.625 hours plus 1.5 hours plus 2 hours. Okay, so 1.5 hours is the waiting, 8.625 is the first flight, and 2 hours is the second flight. So let's see what we get. 8.625 plus 1.5 plus 2 gives us 12.125 hours. 12.125 hours. And they want to know what time he gets to Johannesburg if he leaves at 10 a.m. in Buenos Aires. And so basically what we do is we take 10 a.m. and we add it to 12.125 hours. And that gives us 22.125 hours. Okay? What does that mean? 22.125 hours corresponds to a little bit after 10 p.m. in Buenos Aires. Okay? So it would be 10 p.m. in Buenos Aires, okay, time. The one thing we do need to kind of convert is 0.125 is the minutes part of the hours, right? It's part of an hour. So how do we convert 0.125 hours into minutes? We're going to use the domino, and we're going to convert 1 hour into 60 minutes. And we put hours on the bottom so that we can cancel out the hours, and we put minutes on top so we'll have the minutes left. So we'll have 0.125 times 60. And that'll give us 7.5 minutes. Okay? So it's 0.125 hours is actually 7.5 minutes. So it would be 10:07 and 30 seconds, okay, p.m. And that's in Buenos Aires time. Luckily, they didn't say that we have to give it in Johannesburg time. Otherwise, we'd need to do a time conversion there. So I think that this answer is okay for Buenos Aires time, okay? And that's it for this page.